Hi, my name is Umair Hoodboy. I'm a product manager at Infineta Systems. Infineta provides the world's first and only 10 gigabits per second WAN optimization solution. Infineta's flagship product, the Data Mobility Switch, or DMS, is designed specifically for accelerating data center to data center traffic and can sustain a per connection throughput of up to 1 gigabits per second. In this unedited video, we're going to demonstrate exactly that. We're going to demonstrate a transfer of a 4 gigabyte random file across a WAN with and without the DMS. And we're going to take a close look at the per connection throughput. First, however, let's dive straight into the network topology. This dark cloud in the center, which is labeled opposite, is the WAN emulator. We're going to transfer from west to east, from left to right. From the top left corner, which is the FTP server, we're going to transfer a 4 gigabytes random file to the FTP server is 10.1.1.1. That's the server in the top left corner, and in the top right corner is the FTP client. That's 10.1.1.3. The WAN emulator is an opposite netropy 10G box, which is configured for a 2 gigabit per second WAN link, and it has 25 milliseconds delay injected at each end. So 25 millisecond latency at each end means 50 milliseconds round trip time. So 50 milliseconds round trip time is analogous to US West Coast to Midwest. So think of this as the FTP server being in San Francisco and the FTP client being in Chicago. So let's go ahead and start a baseline, which is an FTP without the DMS. So before we do that, we're going to just do a quick ping test to verify that that round trip time is indeed 50 milliseconds. It is. Now let's go ahead and do a transfer of this file. It's a 4 gigabyte random file, and I want to quickly make a note of one thing, that these DMSs, these Infineta DMSs, are deployed inline. They could have been deployed out of path off of a WAN router, but I've kept things simple and I've just deployed them inline in this example. Now going back to the WAN emulator, taking a close look at the throughput that we're seeing here, we're seeing throughput of about 10 megabits per second. So 10 megabits per second throughput is what we're seeing on a 2 gig provisioned WAN link. That is a problem. That is the problem that TCP has when distances are long. In this case, it's a 50 millisecond round trip time. So 10 megabits per second, the client reports that it would take estimated time of about 55 minutes. Now, this being an unedited video, I'm not going to sit around for 55 minutes, so I'm just going to abort that transfer right now, and we're going to rerun the transfer with acceleration enabled. So the DMSs are deployed inline, however acceleration was disabled in the first run. Now we're going to each DMS. This one you can think of as the one in San Francisco, and the one that I'm configuring right now is, think of this as the one in Chicago. So for both of them right now we're configuring acceleration, and we're going to take a look at how things are with the DMS in place. 55 minutes without the DMS. Let's see how it does with the DMS. So first things first, let's go back to the WAN emulator, and now it's reporting a throughput of about 1 gigabit per second. Let's take a look at the DMS. So the DMS is reporting also upwards of 900 megs per second, which is unparalleled in the industry. A 1 gigabit per second throughput per connection is the point that we're trying to make here. The other thing is, this is a random file. This is a 4 gigabyte random file. So if a file is truly random, you would expect to see no reduction whatsoever. This top pane, the top pane in this dashboard is labeled data reduction, and notice how there's no reduction shown, and that's exactly what you would expect for a truly random file. This test, which I just ran, this transfer, which it looks like it just completed, this is what we call, it's performed on a cold dictionary. In other words, the DMS for every bit seen, every packet seen in this transfer was unique. It was a random file, and so that's why there was no reduction. So this was the cold pass. It looks like it completed in about 40 seconds. So 40 seconds as compared to 55 minutes. That is the difference that the DMS brings. That single connection throughput of 1 gigabits per second. It doesn't matter that there was no reduction seen because of the cold dictionary, it still got a very high throughput. Now we're going to run it again. I've just kickstarted another run, and let's take a look now at the throughput as well as whether we see any reduction. And immediately we see reduction upwards of 90%. In fact, it's like 94%, but the throughput is still 1 gigabit per second. One gigabits per second and a reduction ratio of about 94%, which can be expressed in other words, in other ways, is a capacity increase of about 18x. And it looks like the transfer completed already. Let's take a look at the client real quick. 36 seconds. 36 seconds. So 36 seconds on a warm dictionary, 40 seconds on a cold dictionary, 55 minutes without the DMS. That, folks, is the difference that the DMS brings. A single, a per connection throughput of 1 gigabits per second, and added to that a very low WAN footprint. In this case, we're seeing about 56 megs on the WAN that was taken up. So there you have it, folks. The only product on the market, in the industry, that can do this at high throughput of a per connection throughput of 1 gigabit per second on a 50 millisecond WAN. It still gets a high reduction value. Thanks for watching.